In question 11, it says that the function is defined by f of x is equals to 3 plus 6x minus 2x squared. We have to express f of x in the form a minus b into x minus c whole squared, and then state the range of f. To express f of x in this form, we can first we can do it by completing the square method, or we can do it by the comparison method. So if we just simply expand this expression, this will become x squared minus 2xc plus c squared. Opening up the bracket, we'll get a minus bx squared plus 2xc minus bc squared is equals to 3 plus 6x minus 2x squared. Now comparing the coefficients, the coefficient of x squared over here is minus b, and on the right hand side it is minus 2. So the value of b will be is equals to 2. The constant term is a and minus bc squared. So a minus bc squared will be equals to the constant term over here, which is 3. And the coefficient of x over here is 2c. And okay, so this would have been 2bxc. So this is 2bxc. So 2bc is a coefficient of x, and that is equals to 6. So we have the value of b, which is 2. 2 times 2 is 4. So 4c is equals to 6. So c will be is equals to 3 upon 2. Once we have the value of c as 3 upon 2, we can substitute it over here to find the value of a. So a minus 2 into 3 upon 2 whole square, that will become 9 upon 4 equals to 3. So a is equals to 3 plus 9 upon 2. Simplifying this, we'll get 2 plus 3 is 6. So that will become 15 upon 2. Substituting this over here, we'll get the value. So a is 15 upon 2. So this will become 15 upon 2 minus 2 into x minus 3 upon 2 whole squared. And now as we have to also state the range of the function, and it is an element of real numbers, we know it as it is a negative sign over here, it will have a maximum point. And the turning points in this case are, so the x value is 3 upon 2 comma 15 upon 2. The range of f in this case will become, as it is the highest point is 15 upon 2. So f of x, we can write it over here, f of x will be less than equals to 15 upon 2. In part B, it says the graph of y equals to f of x is transformed to the graph of h of x by reflection in one of the x's followed by translation. Now we already know that the turning points for f of x are at 1.5, 3 upon 2 is 1.5, and 7.5. So this is the general graph. It is first reflected in one of the x's and then translated, and the final function has a minimum point. Minimum point means this graph has been inverted. It means it has been reflected in the x-axis. So in the first step, we'll reflect it in the x-axis. So this point 1.5, this will become 1.5 comma minus 7.5. The graph will become like this in the first step, and these coordinates will be 1.5 comma minus 7.5. As at this point, the value was positive 7.5. Now the minimum point is at the origin, and we have to translate it. So we have to move it 1.5 units back. So first we'll write the reflection is in the x-axis, and then we have a translation. In the x direction, it is minus 1.5, and in the y direction, we have to move it 7.5 units upwards. So that will be 7.5. In part C, it says that the function g is defined by 3 plus 6x minus 2x squared for x less than equals to 0. We have to sketch the graph of g of x and explain why g is a one-to-one function. Now this g of x is exactly the same as the f of x function, and the turning point is at 1.5 and minus 7.5. However, as it is only x is less than equals to 0, so we'll just make this part over here. And to explain why it is a one-to-one function, it means that for every value of y, we have only one value of x. So we can just write for every y value, there is only one x value, which makes it a one-to-one function. In part D, it says sketch the graph of y equals to g inverse of x. Now, the inverse function is basically a reflection of the same graph in the line y equals to x. So in the first step, we'll make the line y equals to x. Okay, so let's say this is passing through the origin. So let's say this is the origin. This is the function g of x. And then to make the graph, so this point will be reflected over here. We can use a different color over here. And once we reflect it over here, this graph will be like this. So this will be the graph of g inverse of x. We also have to find the expression. Now to find the expression, we have to always use the complete square form. The complete square form is 15 upon 2 minus 2 into x minus 3 by 2 whole squared. So this is g of x. To find g inverse, first we'll write y over here. So this will become 15 upon 2 minus 2 into x minus 3 by 2 whole squared. Now changing the values of x and y, we'll get x equals to 15 upon 2 minus 2 into y minus 3 upon 2 whole squared. We have to make y the subject, so we can write it as 2 into y minus 3 by 2 whole squared. We take it on the left hand side and we write it as 15 upon 2 minus x. Now we bring the 2 on this side, so this will become y minus 3 upon 2 whole squared is equals to 15 upon 4 minus 1 upon 2x. And then we take the square root on both the sides. So this will become square root of 15 upon 4 minus 1 upon 2x. And then finally, y will be is equals to, we'll take minus 3 by 2 on this side. So this will become 3 upon 2. And with the square root, we have both plus minus signs over here. And just one small, okay, so this is fine over here. So 3 upon 2 plus minus square root of 15 upon 4 minus half x. Now we also have to decide which of these values do we have to take, 3 upon 2 plus or the minus sign. Now, if we take the positive sign over here, so the value of y will become 3 upon 2 plus and 15 upon 4, and it will exceed this value over here. So let's say if we so if we take the positive value over here, we know from the function that the y value or the inverse function has a range which is always lesser than, the y values will always be less than 0. So if we take a positive value over here, this will make it a positive, and that's not possible. So we'll have to take only the negative value, which is 3 upon 2 minus square root of 15 upon 2 minus 1 upon 2x. And from the graph, we can also observe that for the inverse function, it is always lesser than 0. So we should always have a negative sign over here.